All right, we are going to be using tape diagrams to understand percent problems and represent those percent problems visually using pictorial representation. And then once we've got that tape diagram drawn, we're going to take the numbers and we're going to take our understanding of that tape diagram and we're going to put those values into a table, and that's how we're going to solve our percent increase and decrease problems. So let's get started. All right, so you'll notice it says we've got a cereal box. It says that there's now 20% more, and originally it came with 18.5 ounces of cereal. So how much cereal does the box come with now? So what we're going to want to do is we're going to want to represent this pictorially speaking. So one thing is, when we're dealing with percents, the key indicator in percents is we're always needing to know the 100%. So our pictorial representation is going to start with that 100%. So I'm going to draw my tape, and I'm going to begin by representing that entire tape as 100%. And then I'm going to go back and forth and continue to read the story and add to my picture until my picture is complete. So it says a cereal box says it now contains 20% more, which means it no longer has 100%. That cereal box now has 20% more. So I'm just going to draw a little piece and say it now has an extra 20% in the box. All right, so I took care of that first part. The cereal box now contains 20% more, and that's represented by this little extension down here. Now it says originally it came with 18.5 ounces of cereal. Originally. So what does that originally mean? Originally it came with 18.5 ounces. So what that means is originally it was 18.5 ounces. So I'm going to insert that in blue, and I'm going to say right here, originally it was 18.5 ounces. The original was 18.5 ounces. Now it says, how much cereal does the box come with now? So we are asking, we want to know, how much does the entire box come with now? So we could do this in one step or two steps. So if we want to do it in two steps, we could say, well, first we need to figure out how much is X right there, and then add the little increase to the original amount, and that's going to give us the entirety of the new box. So let's do it that way. Let's start there. So I'm going to take that pictorial representation, I'm going to shrink it down just a little bit, and we're going to use a percent table, because not a percent table, proportions, because this is nothing but a table of proportionality here. And we remember that proportions is x times k is equal to y. And it's going to make our lives a little easier if we think of the x as the whole, the y as the part. And it doesn't matter how many rows we have in our table. So I'll just put a few right there. And then let's start filling it in. So we're going to be looking for equivalent ratios, or ratios that we can record into our table. So let's find a whole. Do I see a whole anywhere? Yeah, 100% is the whole. 100% will always be the whole. So I'm going to record that. It doesn't matter where in that table, as long as I put it in this X column, the whole column. Now 100 has an associated part. What is the associated part that goes with the 100%? It's the 20%, because the cereal box got just a little bit bigger. So it got bigger by some fraction. Haha, did you hear the word fraction? It got bigger by some part. So that is our 20%. So our 100 is the whole and 20 is its associated part. And then let's find another ratio that belongs in this table. So if 100 is our whole and 20 is our part, can we find another ratio? Let's begin by looking for a whole number. Can we find another whole number? Sure we can. We see a whole number right there. Because if 100 was the whole, then 18.5 is a whole. And so let's put that somewhere. And it doesn't matter where we put it. Golly, I'll just put it right here. 18.5 is the whole. And what is the associated part that goes with 18.5? If 18.5 is the whole, what's its associated part? It's the x value right here. So I'll put that into our... And you know what? I don't like the fact that I'm using the letter x as an unknown, but I'm also using x to represent this first column. That's kind of bugging me. So I'm going to change the letter x. I'm going to change that letter to C for cereal. I'm going to use that letter C for cereal. Although technically I could have used any letter, but I'm going to erase that X and I'm going to replace it with the letter C for cereal. I could have used the letter I for the increase. I could have used the letter M for more. It's the 20% more. But I'm just going to use the letter C for cereal. All right, so now I want to do some sort of table manipulation that's going to get me to my missing value C. All right, so vertically speaking, I could, a nice easy way is I could find a unit rate. I could say, well, let's divide by 100. That's going to give me 1, which means I can take this 20 and divide by 100, and that's going to give me 20 hundredths. Yes, it would give me a decimal, but it's much easier for me to just write 20 over 100, 20 divided by 100, and not worry about the decimal. But now that I know that the unit rate represents 20 over 100, then I can just multiply 1 times 18.5 on the left side, and to maintain our proportionality, I'm going to multiply by 18.5 on the right side. So how do we get that value of C? Super easy. All I have to do is multiply 18.5 times 20 hundredths, and that is going to get me my value of C. We're going to do something a little unorthodox here. We're going to put 18.5 over 1 times by 20 over 100. And how are we going to simplify this? Well, we're just going to multiply straight across. So 18.5 times 20. My goodness. 18.3637. So that's going to be 370 over, and then 1 times 100 gives me 100. And simplifying that and reducing it, I end up with 3.7. So C is equal to 3.7. Does that mean we're done? No way, because look back at our pictorial representation. We know that C is equal to 3.7. But the real question is asking, how much does the box of cereal come with now? How much cereal does the box come with now? Which is the entirety of this tape diagram. So that's going to be 18.5 plus 3.7. So 18.5, oh, let's do it in black. 18.5 plus 3.7 is going to give me 2, carry the 1, 2, 1, 22.2 ounces. That's the new answer, the actual final answer, 22.2 ounces. Now, there's another way we could have done it. We could have looked for a horizontal relationship. And I can see that the horizontal relationship, remember, and I'll do this in, let's do this in blue. I'm going to zoom in a little bit. 100 times something gives me 20. Using division, I can see that my constant of proportionality is 20 hundredths. So all the way down here, all I had to do is multiply 18.5 times 20 hundredths, and that's going to give me C. And that's the exact same math we already did right here. 18.5 times 20 hundredths gives us 3.7. And that wraps up this problem where we're discussing percent increase. Our next video, we're going to do percent decrease. And this, both cases, we are reading the problem, we're representing the problem pictorially using a tape diagram, then we're taking our understanding of that tape diagram, putting the values into a table in order to get our answer.